Okay, in this video I'm going to show you how to graph absolute value functions and their characteristics. So the basic absolute value function begins y equals the absolute value of x. Now the absolute value function is really a combination of two functions. Uh, it could actually be written differently as a piecewise function, which I'll show you right here. It could also be written like this with a little brace like that. It's actually the absolute value of x function would equal the graph of positive x, and that would be for x greater than or equals 0. And then actually for less, it also actually is the graph of negative x for x less than 0. And these could be, in this situation, the 0 could be changed a little bit. It's not an important thing at all, but we could have wrote for x greater than 0 and x less than or equals 0. It'd be more commonly written the way I have it first written. So actually, if you can think of graphing the positive x, and just on the right side as a positive x, and then putting the negative x together. But let's go ahead and substitute values. So I'll get the piecewise function away. All right, I'm going to pick 0, and the absolute value when you substitute 0 is 0. So 0 is a point. Okay, when I substitute 1, the absolute value of a positive 1 is just a positive 1. So 1 would be a point on my graph. If I substitute x equal 2, absolute value of 2 is 2. So 2 would be on this graph. So as you can imagine, 3, 3, 4, 4, 4, 4, 6, 6. It just goes through the diagonals. Now, what happens when we pick the negative x values? Well, the absolute value uh, says that when we substitute a negative value in, absolute value of negative is actually positive. So the absolute value of negative 1 is a positive 1. So when we substitute a negative 1, we get an answer of positive 1. So negative 1 positive 1 would be on this graph. Okay, we substitute negative 2, we get a positive 2. If we substitute in a negative 5, we get a positive 5. So on this side of the graph, this is the positive x, y equals positive x. And on this side of them, we get y equals negative x. And so the absolute value is always going to have that sharp point. In this case, the vertex is at 0, 0. Domain, we can substitute any number we want. The range, okay, what answers did we get? The lowest answer we achieved is an answer of 0. We had an answer of 1. We had an answer of 1 from here also. We get answers of 1, we get answers of 2, we get answers of 4. So anything's 0 or above. Interval of increase, okay? The right side of this graph is increasing, and the left side is decreasing. So we start here at x equals 0, okay? And go to the right, the graph will be increasing. It includes 0 because at 0 the graph is increasing. The slope is 0. Okay, interval of decrease. Start over here on this part of the graph and go to the right, it's decreasing. So from negative infinity to 0, the graph is decreasing. X-intercepts, it does touch the x-axis at x equals 0, and the y-intercept. Okay, the right-hand behavior, it really acts like a quadratic function. As x approaches positive infinity, the graph is going up, and the same thing is happening when we go to the left. Okay, the next function I want to graph is y equals negative. So how does that compare to y equal positive square root of x? Absolute value of x, not square root. Y equal negative absolute value of x will be reflection of positive absolute value of x across the x-axis. So the points here, here's a couple points on the absolute value axis. You just simply go through the diagonals. There'll be some points. The graph of absolute value of positive absolute value of x would look like that. The negative would be reflected across the x-axis. So let's see, that would be the point there. This point would go down to 2. This will go down to -5. This point here would go down to -2. This one will go down to -5 also. And all these other points in between. So this blue graph is what we're interested in. So just to compare, it just flips the positive absolute value of x across the x-axis. Domain, all real numbers, no restrictions. The range, again, always determine how low the graph will go. At this point it's at -5. Of course it goes to -6, -7, -8. Anywhere below the x-axis you can imagine. The highest point is at y equals 0. Y equals 0. Interval of increase is just the opposite of the positive square root of x. I keep saying square root of x, absolute value of x. So at the left side of this V shape, graph's increasing, and from the right side it's decreasing. X-intercepts and y-intercepts are the same, right at the origin. Right-hand behavior. Graphs are, both ends are going down. Next example, we'll just shift it left, let's say 3. And how do I make it shift left 3? I group the 3 in with the x. And the absolute value symbols are grouping symbols like parentheses. So if I want to shift y equal absolute value of x to the left, I just put a +3 behind the x, grouped within the absolute value sign. So absolute value of x, the parent function, the basic function, looks like this. So how do I do the absolute value of x plus 3? I just start my vertex to the left 3, and I know absolute value of x will go on these diagonal lines. They just go through the corners. So here is the graph. Shift to left 3. Domain. Range, the lowest answer we get is 0. Highest is any positive number we can imagine. Interval of increase, now this is, again, just don't start on the y value. This is the -3, that's the x value. And interval of decrease, x-intercept, there's one at -3. Y-intercept is the y value at that vertex. That's the lowest spot. Well, no, the y-intercept is where it crossed the y-axis, which is at +3. Right-hand behavior. Left-hand behavior. Okay, the last example I want to do an absolute value, and again we could do a lot more examples, we could shift it up or down, is sometimes within the absolute value sign it might look a little more complicated. Okay, for instance, absolute value of 2x plus 4. Well, let's think of it this way. Before we look inside, okay, let's look behind the function. There's nothing behind the absolute function, so absolute value. So it's not the parent, the basic function is not moved up or down at all. Okay, and of course, looking in front of the absolute, there's no negative sign. If that were the case, it'd be flipped up and down. So no matter, if it looks a little more complicated on the inside, it still means it's a shift left or right. Okay, so how do we figure out what the shift would be? Okay, here's how we do it. Okay, I'm going to set whatever is inside the absolute value. I'm going to set that equal to 0. Okay, alright, and then when I subtract 4 from both sides, I get 2x equal -4. Okay, and divide by 2, and I get x equal -2. So that tells me at what x would the inside of that, the value inside the absolute value be 0. Okay, because I know it's not shifted up or down, so I know my vertex has an answer of y equals 0. So what x would that be? Well, at x equal -2. So that tells me which x to pick. I'm going to pick x to be -2. And if I actually took the time to substitute -2 in for x, which we can do, okay, we find that 2 times a -2 is a -4, plus that 4 would equal 0. So when we substitute -2, we get a 0. So why pick -2? Because we know from looking at it that this is going to be a V shape, and since there's no number behind the absolute value that tells us it's been shifted up or down, we know the vertex is on the x-axis. It's just a matter of where. So it's very useful to know where the where the vertex is. So that's a quick, easy way to find the vertex. We could substitute other numbers in there until we start to see a V shape, but this will automatically tell me what x values to pick to get our V shape. Well, from there on, it's just going to be just go through the diagonals. Go find your vertex. Just draw some points on the diagonals. And there would be our graph. Okay, so characteristics. Again, you can pick any x value you wish. The answers starting at 0. Interval of increase starts at x equal -2. And let's see, the interval of decrease starts at -infinity. It stops at -2. Let's see, the x-intercepts. There's an x-intercept at -2. There's a y-intercept at +2. That's +2 is the y-intercept. -2, that's the x-intercept. right-hand behavior. So if you follow along starting at the linear equations, at this point, right-hand and left-hand behaviors really should know that, but just in case, um, the right end of this graph, as you go to the right, it goes up. So this first part is x approaches positive infinity. Really it's talking about that we're going, the graph is going to the right, and as it goes to the right, this part of the statement tells us that the graph is going up. Okay, and as x approaches negative infinity, that means as the graph is going left, and it's still going up. So there's a lot of other ways we can explore absolute value, but that that'll get a start.